Good morning. Today I am concentrating on the subject concrete technology. So, in the previous I have gone through type of cement, testing of the cement, chemical composition, composition of cement. Now, today we are concentrating on aggregate and test of aggregate. So, we all knows that what is aggregate? Aggregate is a filler with binding material. What is filler? Filler binding material is a cement. So, it's bind with the cement and it acts as a filler, means the voids we can have, we can fill the voids of this binding material cement. We have this filler, it acts as increasing the volume of the concrete. So, it is derived from rocks and it's form a body, it increases the volume of the concrete. But while using your aggregate, it also reduces the shrinkage and it also affects the economy of the construction cost. So, you know that it's like aggregate, it occupies 70 to 80% of volume and it also influence the properties of your concrete. Means if you it depends if which type of concrete you are taking, which size of concrete you are taking. We will discuss in the next slide. So, it is very important to obtain a very good quality of aggregates. So, it is not chemical inert. Before in 1960 we have told that this aggregate is chemically inert, but now through various research it came to know that it is not chemically inert. So, it is a one of chemical bond, it create one chemical bond which have alkali aggregate reaction with the cement paste. It's have this aggregate having volumetric stability and it increases the durability. So, classification based on the size of the aggregate, like we have two types of aggregate, fine aggregate and it varies from fine aggregate, it varies from 75 micron and passing through 4.75 mm. It means that it have a value from 75 micron to 4.75 mm. It means fine aggregate. Fine aggregate means sand, and coarse aggregate which have value between 4.75 to 80 mm. Means it's passed through 4.75 in and retain on 80 mm. So, here we have we can look over the aggregate size, like a fine aggregate. This is fine aggregate. We even call this as sand. This is fine aggregate and this is more finer, like 75 micron, then coarser than this, then coarser, and here we have like more than 4.75 mm. Okay. Here we have this size of aggregate, like coarse aggregate we can vary from this angular aggregate and rounded aggregate. You can see here this have glassy structure, glassy type, and it helps in workability of the concrete, and but here this is a rough surface and angular aggregate, and this helps in creating bond with the concrete. It's create bond with the concrete and it acts as more binding than this aggregate. Now, classification, we can classify aggregate based on its natural or artificial, means geological origin, how it have, like natural also we have, and we have also artificial. On the basis of size, all in aggregate and graded aggregate. We will discuss this. On the basis of shape, we have angular and flaky shape. and basis of unit weight we have normal, heavy and lightweight. So, this geological origin, natural aggregate we have this obtained from crushing rock and also from weathering action, natural agency of rock, and we get mostly from igneous rock. Igneous rock means with the volcanic eruption, the rock we are getting is igneous rock. Now, artificial aggregate is this artificial aggregate not used for RCC work, means where we are doing RCC work. RCC, what do you mean by RCC? Reinforced cement concrete, you must be knowing. So, this artificial aggregate is nothing but broken bricks. At the site the bricks remain bricks bat, so we can use this as a artificial aggregate and we can use for in the foundation work. Then we have blast furnace slag, that is nothing but precast concrete product, and it is have advantage of fire resistant, and but it have corrosion with sulfur. Now, synthetic aggregate we have thermally processed material such as expanded clay and shale. This is also called lightweight aggregate. If we talk about the size of aggregate, we have seen in the previous slide for the size of aggregate, we have different fraction of fine and coarser size. Like fine aggregate we have between 4.75 micron to 4.75 mm, and coarse aggregate from 4.7 to 80 mm it vary. So, all in aggregate means every size we have different fraction of fine and coarse aggregate, means not uniform size, and this type we are not recommended for quality concrete. So, if you are going to construct any buildings or infrastructure, so we are not using this all in aggregate, okay. Graded aggregate we are using for the construction of our projects. So, it's the graded aggregate is the which pass through the ISC, it varies from 75 micron to 80 mm. So, nominal size what we are for normal construction we are using the graded aggregate as 20 mm we are taking for the normal construction, and which passes through 20 mm, means it is more than 20 mm. If we talk about the shape of the aggregate, shape of the aggregate is we have mostly two shape of the aggregate, and we have done this we have done the practical based on this elongated that is called elongated index test and flakiness index test. So, this elongated aggregate, what is this? For what we are calling this as elongated aggregate. If your this aggregate size is 1.8 times, or it is a 9 by 5th times of its mean dimension. Means if you have, suppose you have a half kg of aggregate and you are having the mean size of it, means average size of it. So, it must have the length is 1.8 times of its mean dimension, or it by 9 by 5 times of its mean dimension, then you can call that aggregate as elongated. Let us talk about the flaky aggregate. Your least lateral dimension, it should be less than 0.6 times of or 3/5 of its mean dimension. Means before doing this, I will show you the size shape of the aggregate. This is what we call flaky aggregate, means this flaky width is less, and what and this is elongated aggregate. You can see this is extra long. So, how much long it is? 1.8 times of mean dimension, okay. And And this is flaky aggregate. How much flaky it is? 0.6 times of its mean dimension, 0.6 times of its mean dimension, and this is 1.8 times of its mean dimension. So, this we should know whom we called as flaky and whom we call as elongated. Now, if we talk about the unit weight of the aggregate, we have aggregate of normal weight, heavy weight and light weight, and specific gravity is to vary, like normal weight vary from 2.5 to 2.7, heavy weight vary from 2.8 to 2.9, and unit weight is vary from 23 to 26, and heavy weight 25 to 29, and light weight is 12. If you talk about the bulk density, it varies from 15.2 to 16, heavy weight greater than 20.8 and is lightweight less than 11.20. Example of normal weight, this is sand, and heavy weight scrap iron and lightweight dolomite. So, surface, if we talk about the surface texture, what's the look like a smooth it is or rough it is. So, surface texture, smoothness or roughness, we can talk of an aggregate having glassy surface. For example, black flint having the glassy surface. Then a smooth surface, gravel and marble having the smooth surface. Granular aggregate having like sandstone having granular and rough basalt, and granite having crystalline texture, and this brick and slag having honeycombed or porous. Porous means it can absorb water easily. So, what we call as this ideal aggregate, which aggregate you can call as ideal. So, having all these properties you can call the aggregate as ideal. So, what it should consist of natural stone, gravel or sand in various combination. So, we can call this as ideal aggregate. Should be hard, strong and durable, dense, clear and free from any coating, and it should be free from injurious vegetable matters, and what flaky and this elongated we have talked before. So, it should not be flaky and elongated, and it should not contain any material to attack steel reinforcement in case of reinforced concrete. Okay. What should be the characteristics of the aggregate? Characteristics means like its nature is it should not crack, or it should be free from alkalis, it should not have excessive expansion, and we should have history before we buy or you use this aggregate. Then I have mainly influenced the if your characteristics of aggregate is low, it influences your cement, and ultimately your economy will be affected. So, which type of structure we can use the size of aggregate, like if we are having mass concrete, like mass concrete work, dams or retaining work, where huge amount of concrete are going to be used, piers or abutment, we will use 40 mm size of aggregate. Okay. In RCC work like beams and column, in normal buildings, if you are constructing beams or column, 20 mm will be okay, and for flooring we have 10 mm of aggregate size. Now, this is the properties of aggregate. We have various properties of aggregate like strength, particle shape, specific gravity, bulk density, voids, porosity and moisture content. This all we are going to learn one by one. So, what is how we are determining the strength of the aggregate. So, the strength of the aggregate should be equal to that of concrete, because as we have learned previously that 70 to 80% of the volume of the concrete is occupied by the aggregate. This should have higher compressive strength, and the test conducted should be crushing, impact and 10% fine test. Crushing test is more reliable, and toughness is determined by impact test, and hardness is determined by abrasion test. If we talk for the shape and texture, then shape influence your fresh concrete. Fresh concrete means the concrete in workable stage, in a fluid stage, and hardened concrete also is more than hardened concrete. Okay. So, round and this irregular aggregates are highly workable but ill low strength. If you have round aggregate and irregular aggregate, it is workable but low strength. Flaky aggregate, flaky you have seen 0.6 times of its mean dimension. So, its width is less than 0.6 times of its mean dimension. It requires more cement paste and produce maximum voids. So, it is not economical and we should avoid this. Angular shape is the best one, and this also your shape and texture also govern the requirement of the water. Specific gravity, if we the specific gravity of this natural aggregate lies between 2.6 to 3.5, and influence strength and absorption of the concrete, it also influence. And if your specific gravity is low, then and high porosity, then we have poor durability and your strength will also affected on. Density also depends on your specific gravity. Bulk density and voids. So, bulk density depends on the particle size and grading and moisture content. A higher bulk density will indicate fewer voids to be filled by cement and paste, cement and sand. If the voids are more in the concrete, the strength will be strength will be low, because it acts as a porous material and it increases the permeability. Porosity. So, this porosity is what that entrapped air bubbles in the rock. This entrapped air bubbles in the rock during the formation, and minute holes, have minute holes which is called as pores or cavities. This porosity of rock should be less than 20%, and the concrete if your porosity is more, it will become permeable and affect your bond. So, this porous aggregate absorb more moisture, resulting in loss of workability. Moisture content, high moisture content will increase your water cement ratio, and this percentage of moisture content will also increase the percentage of saturated surface of dry aggregate. If your organic impurities are there in your aggregate, so it will affect your have harmful chemical effect on the concrete, and it also affects the properties of the concrete. This salt, if salt is present, then it will cause the efflorescence, and sulphide also cause surface straining. These are all defects in the concrete, we should be avoided. This alkali aggregate reaction is we have talked earlier that before inert material till 1940 This aggregate is considered as an inert material before 1940, but after that we have seen certain expansion and certain chemical reaction in it, and this have disintegration of concrete having alkali aggregate reaction, and this alkali aggregate reaction is also called concrete cancer. So, this trouble is due to reaction between silica, aggregate and alkali in cement. A reactive aggregate if finally grounded state will inhibit the action. So, reaction between the cement and aggregate of two types, alkalis with either silicates or carbonates in the aggregate. So, reaction with silica is common. So, this alkali aggregate reaction take place only in the presence of water or water vapor. So, the water forms strong caustic solute with the alkali of the cement. So, this caustic liquid attack reactive silica to form alkali silica gel of unlimited swelling type. So, the concept is like this alkali aggregate reaction. We have alkali hydroxide plus silica in aggregate plus water, it forms this alkali aggregate reaction gel. So, it is highly hydrated in the presence of water and reacted aggregates to develop expansion. So, this expansion you can see if your aggregate has suffered from alkali aggregate reaction. So, the result you can see in the picture over here. If we have alkali aggregate reaction, your surface of the concrete after hardening it becomes like this. Okay. So, you can see the crackings over here, and surrounding your house you can observe many alkali aggregate reaction. So, factor affecting your alkali aggregate reaction is, first is reactive type aggregate, that is reactive silica. If it is have serious effect, and if it present in small quantities, it's but not if constitutes the whole of the aggregate, it should be present in a very small quantity. Then second is high alkali content of cement. It should also be present in very small amount, and it have very reactive silica, and but it increase in alkali content and should have greater than 0.6%. So, the cement poses the issue of alkali aggregate reaction. So, it should be less than 0.6%. Then availability of moisture content. So, alkali aggregate reaction occurs only in the presence of moisture. So, this is the reason why alkali aggregate reaction is not observed in the interior mass of the concrete. It looks only on the outer surface of the concrete. Temperature condition should be favorable between 10 to 38%. Okay. So, how can we control this aggregate alkali aggregate reaction? By selecting non-reactive aggregates. So, your aggregates should be non-reactive, it should be maximum to the chemically inert. Then low alkali cement should be there, and moisture content we have to reduce. If your structure water is passing through your structure, we should avoid this. So, and by using your pozzolana, that is reactive silica. So, if your aggregate are to be reactive when it contains silica in a particular proportion and fineness. So, when fly ash or pozzolanic materials we are having as fly ash or suriki or dust is added, if it is added to the optimum condition of silica, in particular proportion, then their fineness is distributed aggregate become passive. Passive means it will not react. And by adding air entraining agent, this is one of the plasticizer. So, by adding this plasticizer also we can avoid this alkali aggregate reaction. So, this alkali silica gel imparts pressure over the set cement gel and can be negated with the addition of water entraining agent and which absorb the osmotic pressure. The other property is soundness. What do you understand by soundness? Soundness is just an expansion of your structure. If your structure is not sound, your structure will expand. So, this condition occurs due to your freezing or thawing temperature, or if there is alternative wet or drying environment. Then this porous and weak aggregate, if your aggregate is having porous or weak, it may undergo volume change. Okay. Thermal properties, this coefficient of thermal expansion of concrete increases with that of coarse aggregate. So, any difference in the coefficient of coarse aggregate and cement paste may break the bond between the two. So, your aggregate should be thermally okay. Now, from here we will going to conduct in the next lecture. This is all testing on the aggregate, that is the fineness modules, the elongation index test, then crushing strength, impact test. This all we are going to see in the next lecture. Thank you.